Namaste, Mata, Pita, Guru, Deva. Welcome back to Pine IT Edu Plus. Today's topic Decision Trees in Python Part 3 Model Overfitting and Underfitting. In machine learning, overfitting and underfitting are two common issues that affect the performance of a model. These problems are related to the model's ability to generalize well to new unseen data, and they occur when the model either learns too much noise from the data or fails to capture the underlying patterns. Overfitting. Overfitting occurs when a model learns not only the underlying patterns in the training data but also the noise, outliers, or random fluctuations. As a result, the model performs well on the training set but poorly on unseen data. This happens when the model is too complex with too many parameters relative to the amount of data. Signs of overfitting. High accuracy on training data, low accuracy on test data. Complex model. Low bias, high variance. Causes of overfitting. Too complex model, insufficient training data, noise in the data. How to prevent overfitting? Use simpler models, cross validation, regularization, pruning, more data. Underfitting. Underfitting occurs when a model is too simple to capture the underlying patterns in the data. It fails to learn the data properly and as a result performs poorly on both the training data and the test data. Underfitting happens when the model has too few parameters or is overly constrained. Signs of underfitting: low accuracy on both training and test data, simple model, high bias, low variance. Causes of underfitting: too simple model, insufficient features, excessive regularization. How to prevent underfitting? Use more complex models, add features, reduce regularization. Bias variance trade off. Both overfitting and underfitting are related to the bias variance trade off. Bias refers to the error introduced by simplifying assumptions made by the model. Variance refers to the model's sensitivity to small fluctuations in the training data. The goal is to find a model with the right balance between bias and variance. Underfitting, high bias, low variance. Overfitting, low bias, high variance. Ideal model, low bias, low variance. The key to improving model performance is selecting a model that captures the underlying patterns without memorizing the noise. How to deal with overfitting and underfitting? For overfitting, simplify the model, increase training data, cross validation, Regularization. For underfitting, use a more complex model, add features, reduce regularization. Holdout validation technique. It is one of the simplest and most commonly used model validation techniques in machine learning. It provides splitting a dataset in two distinct sets, one for training the model and another for testing its performance. The goal of holdout validation is to assess the model's generalization ability by evaluating it on unseen data. What is holdout validation? In holdout validation, the dataset is split into two parts: training set, test set. Typically, the dataset is divided into these two parts with a common split being 80% for training and 20% for testing. Other splits such as 70-30 or 60-40 can also be used based on the dataset size and the problem at hand. Holdout validation is ideal for situations where the dataset is large enough that a significant portion of it can be used for testing. You are performing a quick check on the model's performance before deciding to proceed with more sophisticated methods. Steps involved in holdout validation: split the data, train the model, test the model. Fourth step is model evaluation. Next is advantages of holdout validation: simplicity, fast, good for large data sets. Disadvantages of holdout validation: high variance, next is waste of data, not ideal for small data sets, etc. Example of holdout validation in Python is given. Summary: holdout validation is a simple technique that divides the data into two subsets, one for training and other for testing. It is a quick to implement and works well with large data sets, but it can suffer from high variance if the data is split poorly. For more robust performance estimates, especially with smaller datasets, techniques like k-fold cross validation or stratified k-fold may be preferred. Overall, holdout validation is a good starting point for model evaluation, but care should be taken when interpreting results, particularly with smaller datasets or when the model needs to generalize well. Tenfold cross validation or tenfold CV, also known as tenfold cross validation, is one of the most widely used cross validation techniques in machine learning. It is an extension of k-fold cross validation where the dataset is divided into 10 equal sized folds. In tenfold cross validation, the process of model evaluation is repeated 10 times, each time using a different fold as the test set and the remaining 9 folds as the training set. This helps reducing the variance and provides a more reliable estimate of a model's performance. Steps involved in tenfold cross validation: split the data into 10 folds, train and test the model, compute the average performance, and model selection. Why use tenfold cross validation? Better generalization, less variance, efficient use of data. Advantages of tenfold cross validation: reliable performance estimates, reduces bias, works well with small data sets. Disadvantages of tenfold cross validation: computational cost, time consuming. Tenfold cross validation example in Python is given. Summary: tenfold cross validation is a powerful technique for assessing how well a model generalizes to an independent dataset. It splits the dataset into 10 parts, trains the model 10 times, and tests it on each fold. The average performance across all 10 folds gives a more reliable and robust estimate of the model's ability to perform a new unseen data. This technique is commonly used in many machine learning tasks, including classification, regression, and more, to ensure a model's robustness and reliability. Bootstrap in machine learning. It is a powerful statistical technique used to assess the accuracy of a model or an estimate by resampling data with replacement. This method allows you to simulate the process of drawing new samples from an existing dataset to create multiple subsets which can then be used to estimate the variability of a model or a statistical parameter. Bootstrapping is commonly used for estimating the uncertainty of a model or parameter estimate, creating multiple datasets for model evaluation, bias correction by creating new training sets, and calculating performance metrics. What is bootstrapping? Bootstrapping is a resampling technique where instead of collecting new data, you generate multiple new datasets from the original dataset by randomly sampling data points with replacement. This means that after a data point is selected, it is put back into the dataset, allowing to be selected again. This procedure is repeated many times to create new datasets of the same size as the original. Steps involved in bootstrapping. Create a bootstrap sample, train the model, evaluate the model, repeat the process. And finally, estimate the uncertainty. Advantages of bootstrapping. No assumptions about data distribution, works with small datasets, confidence intervals, flexibility. Disadvantages of bootstrapping. Computationally expensive, requires large enough dataset, overfitting risk. Example of bootstrapping in Python is given. Applications of bootstrapping. Estimating model performance, model comparison, bias correction, uncertainty estimation. Summary. Bootstrapping is a powerful statistical method that involves resampling the dataset with replacement to estimate the distribution of a statistic or model performance. It is particularly useful for estimating the uncertainty of a model's performance and computing confidence intervals without requiring additional data. Although computationally expensive, bootstrapping is valuable when you have limited data or need a robust estimate of model uncertainty. The technique is widely applicable in many areas of machine learning, including classification, regression, model comparison, and uncertainty quantification. That's all for today. We hope you found this tutorial informative and helpful. Detailed PDF notes available. Pay just Rs 49. Share the screenshot with video name and we will send you the notes. Google Pay number is given below. We are also providing online and offline classes on Oracle or MySQL SQL, PLSQL, Python Basics, and Python Advanced on all days from 4 am to 10 pm. For more details, please contact Mrs. Santhu Dinesh +919747006133. She will be available on WhatsApp also. If you have any feedback or suggestions for future videos, please let us know in the comments below. Your support means the world to us. For more videos and tutorials, please visit our channel Pine IT Edu Plus and subscribe. Don't forget to like, share and hit the notification bell. Thanks for watching and we will see you in the next video. Bye.